Alright, welcome. This video is about solving a particular type of differential equation called a separable differential equation. And we're only going to look at first order separable differential equations. The form of a separable differential equation is that the derivative of the mystery function can be posed as a product of a function of x with a function of y. That is to say that we're able to disentangle the x part from the y part. And we would do that in the following way. We would take our dy by dx notation and we'd treat it like a fraction. We would cross multiply by the dx, so bring it up on top to the right hand side, and then divide both sides by the function of y that's on the right. So if we call a function of y g of y, we would divide both sides by g of y. Now what we've done is we've created an expression in terms of y on one side and an expression in terms of x on the other side. They both have a differential, a dy on top on the left, a dx on top on the right, and what we can do afterwards, we can integrate. We can take the antiderivative of both sides. So antiderivative of dy over g of y is equal to the antiderivative of f of x dx. And then what we'll get on the left hand side is some g of y, capital G of y. On the right we'll get some capital F of x plus c. And then we'll try to isolate for y. To get y is equal to some h of capital F of x plus c. So to get a solution, to get a function that meets that requirement. So looking at the layout of what we have here, we have two integrals that we're going to have to do to solve a differential equation of separable form. We're going to have to integrate on the left-hand side and we're going to have to integrate on the right-hand side. That might be the easiest part, to do the antiderivatives. The hard part, very often, is to rearrange to get y all by itself, to isolate for y. And we'll practice some of that too. So we'll start with this nice one. We want to solve the puzzle. Dy by dx is equal to y over x. So what mystery function, if you take its derivative, gives you itself divided by x? So let's do the division thing. I'm going to or cross multiply thing. I'm going to multiply both sides by dx, and I'm going to divide both sides by y. So dy over y is equal to dx over x, and then we'll integrate both sides. So think about substitution. After you do a substitution for an antiderivative, you might have an antiderivative of, let's say, dw over w. This is the same thing on the left. What's the antiderivative of 1 over y with respect to y? Well, it's ln absolute value of y. We get a plus c, but we also get a plus c on the right-hand side. I'll just combine them. Okay, antiderivative of 1 over x is ln absolute value of x plus c. So I'll just put both plus c's together. Then often we can drop the absolute values. Just depends on the structure of the problem, depends on the details. I'm going to pretend that we can. So ln of y is equal to ln of x plus c. Is it possible to get y all by itself? Absolutely. I'm going to exponentiate. I'm going to raise both sides as powers on a base of e. So e to the power of ln y is equal to e to the power, and this is so important, you got to pay close attention. You're raising the entire side on the right as a power on a base of e. So ln of x plus c. That plus c has to be up there in the power. with the ln of x. It's not e to the ln of x plus e to the c. It's so important I want to write that down. This is not e to the ln of x plus e to the c. Instead, what is it? b to the m plus n is b to the m times b to the n. So I'm going to use that on the right-hand side. The left-hand side is beautiful. We just get y. Right-hand side, we have e to the ln of x multiplied by e to the c. That's the b to the n, b to the m times b to the n. Now I can cancel the e ln x now. And we get y is equal to x times e to the c. I'm going to let a equal e to the c. C is an arbitrary constant. A is just e to the power of the arbitrary constant. It's just a different arbitrary constant. So I have y is equal to a times x. That's the answer. Solution. With some arbitrary constant a. Let's check. Now, this is the first time doing one from scratch. Let's check to see if this meets the criteria. So I have d by dx of ax is equal to ax over x. Is this true or false? I'm replacing y on both sides of the original expression with a times x. So the derivative of a times x is a. Ax over x, that's a, is true. So it solved the puzzle. It met the criteria. Here's another one. We're going to do the same thing to start with. This one has a condition. Y of 1 is equal to 4e. So first step, let's get all the y stuff on one side and all the x stuff on the other side. So right now I have a y on top on the right. I'm going to divide both sides by y. And then we always cross multiply by the dx. So dy over y is equal to 2x dx. And then integrate both sides. On the left, we have ln of y. I'm just going to skip the absolute value thing for differential equations. I have good reasons for that. On the right, we have x squared plus c. Next, I'm going to rearrange and get y all by itself. Once in a while, I'll do something different. I'll say, let's find c. Let's find that constant. Using y of 1 is equal to 4e. So replace the y with a 4e, replace the x with a 1, rearrange and get c. But for this one, I'm just, for reasons that I don't want to get into, I'm gonna get y all by itself first, and then use the condition. So to get y all by itself, we have to exponentiate both sides. E to the ln y is equal to e to the x squared plus c, and make sure the plus c is up there with the x squared. It's not e to the x squared plus e to the c. It's got to be all in one power. Then in the next line, I'm going to use b to the m plus n is b to the m times b to the n. I'm going to use the exponent law again, and I'm going to use the cancellation law. So we have y is equal to e to the x squared times e to the c. And in the next line, we'll let a equal e to the c. So we have y is equal to a e to the x to the 2. And we're not done. Now we use the initial condition. Use y is equal to 4e when x is equal to 1 to find a, to find our constant. So I'm going to replace the y with a 4e. So 4e is equal to a times e to the power of 1 squared. So 4e is equal to a times e. 1 squared is 1. E to the 1 is just e. Divide both sides by e. So a is equal to 4. And we can make our conclusion, thus, the solution to our differential equation, y is equal to 4e to the x to the 2. Alright, there you have it. And I'll leave it to you to check. If you take the derivative of this, do you get 2x multiplied by itself? And if you evaluate this at 1, do you get 4 times e? Okay, another example. We have a differential equation dy over dx is equal to cos of x over e to the power y with the condition y of 0 is equal to 0. We're going to do the separation process. We're going to get the e to the y to the other side. How do we do that? We have to multiply both sides by e to the y. So e to the y dy, and we always multiply both sides by the dx. So cos of x dx, and then integrate both sides. Okay, antiderivative of e to the y with respect to y is just e to the y. Antiderivative of cosine of x is positive sine of x. And we'll put a 1 plus c, put it just on the right hand side. Next, how do we get y all by itself? Well, this time we have to take the log of both sides. So ln, natural log of the left side is equal to the ln, natural log of the right side, sine of x plus c. And the plus c has to be inside that log function with the sine of x, not plus c on its own after. Okay, we have a cancellation law on the left. So y is equal to the ln of the sine of x plus c. Now we're going to have to find that c using our condition. Use y equals 0 when x is equal to 0 to find c. So 0 and 0. 0 is equal to the ln of the sine of 0 plus c. Sine of 0 is 0. So 0 is the ln of 0 plus c. So 0 is equal to the ln of c. I'm going to get that all by itself by exponentiating. Raise both sides as powers on a base of e. So e to the 0 is equal to e to the ln c. Cancel the e ln on the right. E to the 0 is 1, so we get 1 is equal to c. And we can make our conclusion. Thus, y is equal to the ln of the sine of x plus 1. And I'll leave it up to you to confirm that this is correct. To check, if you take the derivative of this, does it equal to the cosine of x divided by e to the power of this function? And also, does this function give you a y value of 0 when x is 0? Okay, here's another one. This time it says y prime. So my first step is I'm going to rewrite it as dy by dx. Recognizing that if we're going to treat this as a separable differential equation, I have to have something I can separate. So I have to be able to separate out the differential. So let's get the y down on the other side. dy over y is equal to x sine of x times dx. Now we're going to integrate both sides. We've done the one on the left a few times already. Antiderivative of 1 over y with respect to y is ln y. We'll pretend the absolute value thing is not a problem. How about the right-hand side? What method do we use? And the answer is integration by parts. IBP. So late. We don't, on the right-hand side, we don't have a log, but we do have an algebraic. So I'm going to let u equal x. And that means dv is equal to sine of x dx. So du by dx is equal to 1. So du is equal to dx. And then v is the integral of the sine of x dx, which is negative cosine of x. So we'll take those ingredients and plug them all into the next line, our uv minus the integral of v du, integration by parts formula. So we have ln y is equal to u times v, x times negative cosine of x, minus the integral of v, so negative cosine of x, times du, which is dx. So we have ln y is equal to negative x cosine of x. And what's the antiderivative of cos? Positive sine. And we'll tack on our plus c at this point. So in the last example, what we did was we rearranged the expression and then we solved for c. And I'm going to show you that we could solve for c here and then rearrange the expression after. Now, use y is equal to 3 when x is equal to 0 to find c. So ln of 3 is equal to 0 plus sine of 0, which is 0, plus c. So ln of 3 is equal to c. And we exponentiate e to ln 3. Oh no, that's it. Just c is equal to ln 3. We're done. Okay, now we have thus ln y is equal to negative x times the cosine of x plus the sine of x plus ln 3. And we can get y all by itself by raising both sides as powers on a base of e. So e to ln y is equal to e to the power of the right hand side, negative x cos of x plus the sine of x plus ln 3. And we're going to use that exponent law. Use b to the m plus n is b to the m times b to the n. So we get our final answer. Y is equal to e to the negative x cosine of x times e to the sine of x times e to the ln 3. And I'm a liar, we're not done yet. We have an e to the ln 3 there at the end. So I'm going to cancel it, put the 3 out front. 3 times e to the negative x cosine of x times e to the sine of x. And that's super complicated. It makes me worry that something was done wrong, how complicated that function is. I trust that you'll let me know if there is something wrong. Shoot me an email. Okay, where are we with time? Another example, I think. Yeah, okay. So a differential equation, y prime is equal to a function with a mixture of x's and y's. So I'm going to put a little comment here. We will need to work a bit to write the differential equation as dy by dx is equal to f of x times g of y, because right now it's not. It's not written in that separable form. So what we'll do is we will use b to the m minus n, or b to the m plus n. Oh, let's go b to the m minus n. Why not? subtract it. Let's go all the way, use a proper exponent law. B to the n minus n is b to the m divided by b to the n. So this means e to the x squared minus y we can write as e to the x squared divided by e to the y. And now it's going to be separable. So let's write down our differential equation. Y prime is the same as dy by dx is equal to x times e to the x squared over e to the y. I'm going to cross multiply. So e to the y dy is equal to x e to the x squared dx. On the left hand side, let's integrate. Don't forget to integrate. Left hand side, antiderivative of e to the y with respect to y is just e to the y. Right hand side, we need substitution. So I'm going to let w equal x squared. So then dw by dx is equal to 2x. And that means dx is dw divided by 2x. So we'll have an integral x times e to the w multiplied by dw over 2x. The x's cancel, so we've completely transformed the right hand side. It's all that stuff from before, it doesn't get thrown away. We could put the 1/2 out front. There's a 2 in the denominator there underneath the dw. Well, I'll just put the denominator in front of the integral to make it cleaner. So e to the y is equal to antiderivative of e to the w is just e to the w plus c. And then we can undo the substitution. So e to the y is equal to 1/2 e to the x squared plus c. Now what do? Well, we have to use the condition. We have to find c. We'll use y is equal to 7 when x is equal to 0 to find c. So e to the power of 7 is equal to 1/2 e to the power of 0 plus c. And that means e to the 7 is equal to 1/2 plus c, since e to the 0 is 1. And that means c is equal to e to the 7 minus 1/2. Thus, we're almost there. E to the y is equal to 1/2 e to the x to the 2 plus e to the 7 minus 1/2. And our last step, to get y all by itself, we can take a ln on both sides. And y is equal to the ln of 1/2 e to the x to the 2 plus e to the 7 minus 1/2. All right, well, this next problem is a little bit more interesting. It's going to require that we do something we haven't had to do, and that's to use partial fractions. So we'll start the usual way. I'm going to bring all the y stuff underneath the dy, or on that side, left-hand side, and cross multiply by dx. So left-hand side, we're going to divide both sides by y, divide both sides by 100 minus y. And then integrate both sides. Well, on the right-hand side, it's pretty easy. Antiderivative of dx, of 1 times dx is just x plus c. Left-hand side's trickier. We got to do partial fractions. So I'll write that down. Partial fractions 1 over y times 100 minus y, written as an unknown constant a over the first term plus an unknown constant b over the second term. We'll multiply all three pieces by y, we'll multiply all three pieces by 100 minus y and cancel. And what we'll find is this: 1 is equal to a times 100 minus y plus b times y. This is true for all values of y, and we're going to be strategic. We're going to choose smart values of y. I'm going to choose y equals 0. So if I do that, we'll get 1 is equal to a times 100 minus 0 plus b times 0. So 1 is equal to a times 100, and that means a is equal to 1 over 100. And now we need to find the b value. We find the b value if we let y equal 100. So if we do that, we get 1 is equal to a times 100 minus 100 plus b times 100. And we find 1 is equal to 100b. 100 minus 100 is 0, so that first term disappears. So b is equal to 1 over 100. So this integral on the left-hand side becomes an integral of a over y, so 1 over 100 over y, plus 1 over 100 over 100 minus y, integrated with respect to y. Okay, and then that can be split into two antiderivatives. We have 1 over 100 times the integral of 1 over y dy plus 1 over 100 times the integral of 1 over 100 minus y dy is equal to x plus c. Antiderivative of 1 over y is ln y, so 1 over 100 ln y plus 1 over 100, and the antiderivative of the next one is negative ln 100 minus y. And you'd get that by doing substitution, let w equal 100 minus y. We'll go through the steps, you'll get this. Now we have a bit of a mess here. We have lots of fractions. I want to get rid of those fractions, so I'm going to multiply both sides by 100. So we have ln y minus the ln of 100 minus y is equal to 100x plus 100c. And now we can use the condition, find the value of c using y of 0 is equal to 10. So ln of 10, replacing all the y values with 10, replacing all the x values with 0. Ln of 10 minus the ln of 90 is equal to 0 plus 100c. And I'm going to use a little trick here. I'm going to use a log property. Log of m minus log of n is log of m divided by n, so 10 over 90 inside the log is equal to 100c. And that means c is equal to 1 over 100 times the ln of 1 over 9. So thus ln y minus the ln of 100 minus y is equal to 100x plus the ln of 1 over 9. So what happened there is we have a 100 times c, and c is equal to 1 over 100 times ln of 1 over 9, so the 100 and 1 over 100 cancel. Now I mentioned at the top right there that it's very hard to isolate for y. I'll attach that process I'll just tack that on, but it's not something you'd have to do. But some of you are going to be curious about can you get y all by itself? And the way that you would do that, the hint for that is one of the things we had to do to get c into a nice form. You have to use a log property. Use a log property, rearrange, then cross multiply, expand, collect like terms, factor, and then divide. It's a long process, but it's a mechanical one. I'll show you how it works, but it's not, again, don't worry about it. Don't worry about doing it yourself. What comes out of that isolation process is something that looks like this, something that has this form. It's called a logistic function. E to the x over 1 plus e to the x, or equivalently 1 over 1 plus e to the negative x. Both of those are the same. You can multiply the second one on top and bottom by e to the x, so multiply by 1, and expand in the bottom and simplify, and you'll see that they're the same. And look at the differential equation we had. dy by dx is equal to y times 100 minus y. Well, that's like one of those population models with the carrying capacity. The rate of change of the population is equal to population multiplied by the carrying capacity minus the population. Because when the population reaches the carrying capacity, the rate of change will go to 0. If the population exceeds the carrying capacity of the environment, then the rate of change becomes negative. And it gives us this nice curve of a initially exponentially increasing population that levels off to some value. This curve does not just appear in population dynamics. It appears in chemistry, it appears in physics and business, economics. It appears all different types of places. It also mathematically describes the spread of memes. Like down here, at the early part of a meme, how many people have been exposed to a meme when the picture first gets created and posted to some page? 10 people, right? 10 people see it, they think it's funny, and they share it. And then most of us, well, I used to count myself in this group, but I'm getting old. But somewhere around here, you will see it. You'll start spreading on social media, you'll see it there. And then I'll probably see it around here. And then the really uncool people will see it over there. And your parents, your super uncool parents, will see it over here. And then grandma will start forwarding it on Facebook over here. So that's the life of the meme. It's just what percentage of the population sees it. It can't exceed 100% of the population. So it's eventually everyone's gonna see it. Everybody's gonna get rickrolled. Everybody's gonna get. Let's see. I'm out of date, so I'm afraid to say anything other than rickroll, which is super old. But memes follow the same. They follow the same sigmoid curve. It's like a universal curve for lots and lots of things. So that differential equation, the one we just solved, is kind of famous. And we'll continue in the next video.